muted. Oh, hi. So I muted myself there. Anyway, yeah. Hi to the stream. Advent of Code, day 19 today. In case you haven't seen the previous two streams, I will use Go to just solve the current Advent of Code problems. And the goal will be to first just kind of get the stars as quickly as possible. And then once we got the stars, if we still have time, I usually aim for at most 2 hours or so. I will then try to refactor the code into a form that I would probably use if I was actually trying to write like Go seriously. I have not looked at the problem yet, so let's just do this together. Day 19, monster messages. You land in an airport surrounded by dense forest. As you walk to your high-speed train, the elves at the Mythical Information Bureau contact you again. They think their satellite has collected an image of a sea monster. Unfortunately, the connection to the satellite is having problems, and many of the messages sent back from the satellite have been corrupted. They sent you a list of the rules valid messages should obey and a list of received messages they've collected so far. Your puzzle input. The rules for valid messages, the top part of your puzzle input, are numbered and built upon each other. For example, this. Okay, some rules simply match a single character, in this case B. The remaining rules list the subrules that must be followed. For example, the rule 0, 1, 2 means that to match rule 0, the text being checked must match rule 1, and the text after the part that matched rule 1 must then match rule 2. Okay, fine. It's basically eBNF form. Some of the rules have multiple lists of subrules separated by a pipe. This means that at least one list of subrules must match. The ones that match might be different. Wait, some list of subrules separated by a pipe. At least one, yeah, okay. Might be different. For example, the rule this whatever means the text. Yeah, I guess that's pretty clear. As I said, eBNF basically. There are no loops in the rules, so the list of possible matches will be finite. Since rule 1 matches A and rule 3 matches B, rule 2 matches either A or B, or AB or BA. Therefore, rule 0 matches AAB. I can't really pass that, but I think I understand what the problem is, so I hope that's fine. Yeah, so here's a more interesting example, because rule 4 matches that... Wait, rule 4 matches A and rule 5 matches B. Rule 2 matches 2 letters that are the same, AA or BB. And rule 3 matches 2 letters that are different, AB or BA. Since rule 1 matches rule 2 and 3 once each in either order, it must match 2 pairs of letters, one pair with matching letters and one pair with different letters. This leaves 8 possibilities, AAAB. Okay, whatever, I think I understand how this rule set works. The received messages need to be checked against the rules so that you can determine which are valid and which are corrupted, including the rules and the messages together. This might look like. Your goal is to determine the number of messages that completely match rule 0. Okay, that's also fine. Yeah, so as most Summer of Code problems, this seems to come down to write a parser for our bespoke format first, and then the actual matching should be pretty simple. So let's start. I should also, let me just tweet out that I'm actually streaming now, just for posterity. Okay, cool. So we start with the same boilerplate we always start with, and we take a reader and we return. I guess we return a list of rules and an error. Out. So we still have, we have to define what a rule is, but we can actually, let's just do it this way. Let's use an interface as a kind of substitution for a sum type. So a rule is anything. Well, we will see what a rule is later. Like for now, it's just anything. So out will be list of rules. This will be our output, and then we create a scanner. To go line-wise through the input. And if there's an error, we will just return it. Okay, so now we need to actually pass every rule. So we will, I guess we will do a separate function for that. Pass rule of the text. And if there's an error in that, we will just return it. And now, so how does rule parsing work? So we know I will just copy and paste this test input over here. Let me also increase the font size to make it easier to read. And I will also just enable syntax highlighting. Okay, so the rules are at the bottom, at the top. So every rule starts with an index of the rule. It's a bit weird. Like theoretically, the index could mismatch the line, but we will not care about that for now and hope that it always matches. So it always starts with an index and then a colon and then the actual rule. So we will just find the colon. Oh, by the way, we should also here, if the text we receive, is, if the line is empty, this is a signal that we are done with the rules and we should continue on. So we will add that. And if there is no colon, then of course we return an error. Otherwise, we just take the rest of the line and trim the space off of it. And now we should be left with the actual rule definition. And I guess we have, like, the problem statement said that some rules simply match a single character. I guess, like, the question is, can an alternation also list more than one character? And we will just look quickly at the input to see if that ever happens. And it doesn't appear that way. So we always either have just a single character or we have a more complicated alternation. So let's first deal with the single character case. If the rule is empty, we will return an empty rule. Otherwise, we can say if L0 is a quotation thing, then well, we can just say if the last character isn't a quotation mark, we return null. Otherwise, we return and now we actually have to return a rule. So we will define our first concrete rule type as a literal. Many typos. And I guess we can just say the literal is a literal string. And say we return a literal L from 1 to len L minus 1. And this will be our first rule type. And now we have we have dealt with the single characters. So now we will do a like all the rest of the rules engine. And the way we will do this is we will first see if it's an alternation. So we will first check for the pipe symbol and then do the concatenation. So first we will do a split of the line by a pipe character. And if this is just, if we can, let's first actually say, yeah, no. So if we only have, we have more than one, we have an alternation. Otherwise we don't. Let's see how we best, I think I will do a subfunction for that, because basically we want to, like, when we have an alternation, we want to do the same thing to each side of the string as we would do if we don't. So we will just do a, I guess we can also do a, can just range over SP, and it might be just one element, and that would also be fine. Okay, and so on each piece, we will first trim all the space away, and then we will split that again. And I'm shadowing SP here because we don't care about the previous SP. Hi, Paschalis? I don't want to mispronounce your name. I don't know you, so I'm happy you're saying hi. Hope you stay. And hi, Michael, of course. I do know you, so I don't care about you. Okay, we will split the rest by spaces, and then we will have a concatenation rule, which is just a slice of rules, which will say, I first want to match the first, the second, and the third, and so on. And we say, this is a concatenation, and then for each piece again, we will first trim the spaces, and then this will always should always be an integer. So and if the error is not null, could not pass rule ref %q, and then we will just wrap it and return it. Otherwise, and we need another new rule type, which will just contain an int. We will, like, the thing is, we will at some point have to think about how we will resolve references, because to resolve them we need we first need to have all rules. But for now we will just pass that as an int and see what happens. So r equals append r a ref v. And now r should be the concatenation of all the pieces on this instance of the alternation we look at. And so we also define an alternation type, which will also be a slice of rules. And this will be our outermost time. Our outermost rule, like every rule will be more or less an alternation. And so once we passed our concatenation, we will say a equals append our concatenation rule. And at this point, a should be correctly passed, I would think. Let me think about that for 1 second before continuing. Oh, oops. There's a range missing here. Yeah, that sounds fine. And now we will just for convenience, we can just return the alternation. I guess it doesn't hurt. But we could also just say, like, if len a equals 1, we will return a 0. There's no reason for an extra indirection. Otherwise, we return a with a nil error in each case. And then we hope that this is that we wrote our parser correctly. Oh, this. Yeah, let me just change this into an L. This is easier. And now let's see whether this compiles. Undefined error. Invalid operation. Oops, this is not scan, this is R, of course. Missing return. Return out nil. And now S is undefined. Yes. Okay, now it compiles. And now I would like to see whether it does what we expect on the test input. And for that, I will use good old printf debugging. So I will define a string function on every rule type. That will just output it literally. Should of course also return a string. So we will first call the we will just add a string method to the rule type so that we can call it and say append the subrule string, and then we will say fim dot return strings dot join the parts by. So basically we will undo all our parsing again, but that's fine, I think. Var this will basically be the same, just that this will be joined by a pipe symbol. So this seems like it should print something. It might not be correctly so just to make things visually distinct, I want to make sure that if I accidentally delineated the parts wrongly, there's at least some visual signal of where one part ends and one part begins and one part ends. And so we will here also do a fim.println of the rule and see what happens. And we will paste the test input we have here. And it doesn't do anything. What? Oh, it doesn't do anything. Surprisingly. Okay, so let's again try to build it and see what happens. Does not contain the same thing I did yesterday. Undefined R. And so yeah, so the first rule is ref 415. This looks great. This is obviously broken because I am a mug. Okay. This also seems to pass fine. Yeah, this all seems to pass fine. Right. Great. I also do want to have so let me instead of writing something to check whether you see the rule numbers are not sequential. Bugger. So we need to change things a little bit around. We will say that the rule will also have an index. Will we? Should we? Must we? Yeah. And now we will make them all structs. I kind of don't want to do this right now. Let's instead return from parse rule also the index as an int. And so this will be great. And now we also have to add something to every return. There are probably tools that can do this, but I don't have any installed, and I don't like. For me to use a new tool, it first has to become part of my muscle memory, and in my experience, that really that takes a while. So this will also have an IDX, and now instead of appending to out, we will say if len out is less than the index, wait, the index less or equal the index, we will say out equals make rule IDX and say copy temp from out, and then set out to temp, and then set out IDX to the rule. So this should also be, this should probably be fine. Index out of range, 0 is length 0, frick. If len out is I guess this must be less than IDX after all, but like, doesn't it really have to be, if the index is 1, length has to be 2. Whatever. Still not enough. Wait, what am I misunderstanding? Someone want to chime in and tell me where I'm being dumb? If the index of the rule is bigger than this is so typical. If length is 0 and index is 0, this should trigger. So if index is this does seem right? But it says index out of range. Like, does it say? Yeah, it does. Oh, yes. Okay. So yeah. Let's do this, or let's do again, just to verify that we have parsed everything correctly. Nope. Oh God, maybe it would be simpler to add an index to every rule after all. Yeah. Still not correct. Oh. God damn it. Sorry. Typical. Okay, better. We don't have enough rules. We are missing 2 rules. Also, the indices are all wrong, because I also did the same thing over here with the literal thing. Now we have all the right rules with the right indices. Okay. Okay, so much for that. So what next? Next we would have to actually evaluate the rules on the rest of the inputs. Oops. Why? So we have found our line, and so we will now for the rest of the line. Actually, we should just after all, our function is called parse input and not just parse rules. So we rename that to rules, and we will say for words and we will collect all the words we should check as well. And then we also need to do an additional nil here. And we say rules words are great. Okay, and now we should say we want to count all the words that match rule 0, right? Var n and for all the words, range words, if rule 0 dot matches the word, and we have not defined what matches does yet, but we will do in a second, and plus plus percent the words match the rules. Okay, now we need matches, so we need to actually say that our rules should be able to say whether a string matches this rule, and for for literals this is very simple to implement. Bool s equals string r, and then for concatenation we will run into a problem because our matches do just say whether the whole string matches and not how much of the string matches. So we will say whether it matches and return the rest. If strings dot this changes this function. If strings has the prefix r, then obviously the string matches the literal. So we say this returns true and the rest of the string. Correct? Yes, correct. Otherwise we return false and this and the unmatched part, and in this case exactly the same. Okay, so for every subrule in the concatenation, we say okay, rest is r dot matches s. If not okay, return false s. Otherwise, so now we will just go we will go through all rules, check them each individual, and as soon as one of them no longer matches, we know that the concatenation doesn't match, right? So if this and if it matches, we say as is the rest, and now we know that we are done and everything matches, so we return as true and the rest of the string. Hopefully this works. Alternation matches as string, and now we will say this is actually we have to check what happens if more than one rule can match. For example, means that to match rule 2, the text being checked must match rule followed by, or it must match. Fortunately, there are no loops. The received message need to be checked. This is not helpful. Some of the rules, multiple list of subrules separated by a pipe. This means that at least one must match. The ones that match might be different each time. For example, the rule means that to match rule 2, the text being checked must match rule 1 followed by rule 2, or it must match that by that. There are no loops. Since rule 1 matches, here's a more interesting example. Since rule and it must match isn't terribly specific, so I will assume that we will have to check each of them. And if oh yeah, we will. This doesn't matter. Because the subrule matching will already do if there are multiple matches, we can just return any of them, and if there aren't, we will just try the next. No, but this is the problem. The problem is if there are multiple matches, the rest of the string is no longer well defined. Because if there are multiple matches, there might be matches of different lengths. So we have to this thing no longer really works because we can now have multiple matches returned. Cool. So next variation of this rule. We return a slice of all the possible rests, and if the slice has length nil, there is no rest. Hi Tim. Hope you like it. Okay, so next iteration of the rule. So if this matches, then we will return a slice of string. So it's just to be clear, the issue is. So far we've always returned whether it matches and the rest of the string, but if we have a rule of the form, say 1 2 3 1 or whatever, and then we try to match let's say 1 is A or whatever, if we try to match ABC D, then this could either mean we match ABC and the rest is D, or we just match A and the rest is BCD. And while this doesn't matter for if we just want to determine if it matches or not, it matters because if we then concatenate that with another rule, this rule might start with a B or it might start with a D, and depending on that, it might or might not match. And if we only return one of the matches, this won't give us like everything we need. And so we actually need to collect all possible rests that could remain. Okay, so rests are r.matches of the string if len rests greater than 0. No, if it's 0, this means nothing matched, and we will return nil. Right, like if any in the concatenation, if any individual element doesn't match, we can just immediately return nil. Otherwise, we will return the string, because there can only be one rest. And this will be this is the more complicated thing. Oh, and we will run into the ref problem very soon. So the alternation, how will that work? Again, we will go through all these subrules. We will say we will match that, and we also want to return, of course, slice of string here. And we will actually, I think in this case we can actually just do this, because now, like, whenever one of those returns a zero length slice for it doesn't match, then it will just not append anything. But if it appends, like if it does match something, we will just add it to the list of possible matches. So the list of possible matches that we output in the alternation is the union of all the individual matches. Hi, Shakil. Cool. So this, so far so good. I think this does feel. I'm casually optimistic. Now the ref part is the more interesting part, because so far we've only had a the ref is just an integer, and so if we want to know if this ref actually matched, we have to be able to see what rules this is referencing, or what rule this is referencing, to call its match function. And I think the way I want to solve this is to say, to make ref a struct after all, and just retain a subrule in here. Oh, we can actually just embed that. That would be, I think this is actually pretty nice. We will just embed rules, then we don't, oops. Wait, where am I? What happened? What did I do? So we don't even need this function. Oh, we will implement it just to be clear, just for clarity's sake. And so this will hold the resolved rule. And then we will just, in a separate step, resolve all the subreferences from the rule slice. And so the ref matches, it will just return r dot matches s. So it will just match the subrule and return that directly. And here we will do something. If r.r is not nil, we will return dot string. So this means we will actually, like, when we get a reference and reprint it after we resolved it, we will actually get what the subrule is, it matches. And the problem stated that there are no loops. So normally we would have to be concerned whether this could be an endless loop, but in this case we don't. So we would just use that. And then we need to have a function that resolves the subrules. And we will write that here. Resolve refs. And it takes a slice of rule, and we'll just modify that. Range rs. And I think one thing we will do is we will sort the rules to make resolution easier, because not only are the integers not consecutive. Again, if we look at the input, the rule indices are not consecutive, but we also like they are not just sorted, and not just not sorted, but they might also not be contiguous. Like there might be gaps in there. So we will sort the slice. Oh, if we sort it, of course, we will lose the index of the thing. So can we yeah, we can solve that. Let me see. So the issue is, if we sort the rules, we do get, like, do we care? Do we honestly care? It's less than 100 rules, we don't care. We will just take the hit of the quadratic linear search. That's just easier. So we will say, we will go through all the rules. The rule might be null, or we will actually just say, if the rule is a ref, and now I want to verify that I didn't use pointer receivers. No, I didn't. But I need to do this. So if the rule is a ref, like if it isn't a ref, we don't have to resolve it. Otherwise, we can look at what the value of the ref is, the index it's referencing, and that will be the referenced value. So we can say rf.r is this. One thing I want to catch here, I think, is the value might be, the reference might be invalid, theoretically speaking. So I will just say, if it's null, this means, like, because we just insert every rule at the index it references, if an index does not have a definition, it will just default to the 0 value of rule, which is null because it's an interface. We say unresolved reference to rule D, which will be this. And then we say RSI equals the modified ref, because none of these are pointers, because why would they? Yeah, so this looks like it should do what we want. And so what we will do first here is just print, again, just to make sure everything is in order, we will print the rules that we passed. Then we will call resolve refs on the rules. And now I will print the rules again, for the simple reason that I want to see that, like, whether all the references are correctly resolved. Unexpected new line or whatever. Makes sense. Unexpected comma also makes sense. Cannot use this as a value also makes sense. And the same is here. Non-bool, rules, matches, whatever, used as if condition. 33. if len that, so we should actually say, okay, again, rule question is do we not need to match the entire string, or do we just need to match a part of the string? The completely match rule. Okay, so if they have to completely match, we have to say matches v. So the check for completely matched is there must be exactly one rest. I guess there could be more than one. Theoretically, there could be more than one. There could be the empty string more than once. So yeah. How do I best do that? Func represents match, just for clarity's sake. So because the alternation, like both sides of the alternation could match the entire string, it could actually return 2 empty strings as the rests, and not just one. But an empty string basically represents I match the entire string. So for if there's a non-empty string, return false. Otherwise, return len r is greater than 0. So if represents match rules 0.matches, increment the number of rule matches. Undefined r. Not enough arguments. Return nil r. The same in line number 2. Return. No, not return. Continue, of course. 102. Too many arguments, makes sense. Undefined rest. S equals rests. This doesn't work. Okay, now each thing in the concatenation can match multiple things, and we actually need to branch out and check each part. So this is getting we see where the computational complexity lies, like, because we need to do all this backtracking. So we actually need to say, wait, how do we do this best? What if there is more than one rest? So we need to say, so we need to keep a list of all the possible rests. This is becoming more complicated than I thought, I must say. And now we have to actually go through all the possible rests. So rests will be initialized just to S. And like for each of these, check if it matches. And if it matches, we have to add it to the list of rests, which var next. Yeah, var next string. Oh, we also need to mark the ones that haven't matched. Okay, this is becoming a lot more complicated right now. Because like we basically like don't just have to go through all the rules. Like there will be like a tree of possible matches, and if one rule does not match at all, wait, do we care? No, I don't think we do. I don't think we do care very much. I think this works. Hi, Ricky. This is what this is. It's me trying to solve the current advent of code problem. If you haven't heard of it, it's adventofcode.com, and there's an explanation of what I'm trying to do right now. Okay. Oh, this is doing my head in. Wait, this is a concatenation, so one after the other has to match. Every match gives you a range. Oh, this can't be this hard. So the problem I'm having is, let me actually get rid of all of this. So what we have to contend with is we are looking at something like this, right? And now the question is, what if one of them matches multiple things? So say one matches and says like say we put in this string, I don't know. I can't come up with a very concrete example, but say let's say one has the rest like ABCD, but it also has as a possible rest CD or whatever, right? Like it matches two pieces of different lengths. If that's the case, we must throw rule 2 against both of these, and now rule 2 might match this. Actually, this works, right? Like no matter what, it will give you a list of options that you can pass to 3. Yeah, I do think this actually, yeah, what I thought would work, I think this actually does work. So we keep a list of the possible matches that are still left. And just for a bit of efficiency, we will use a set, because it might be a hash set, because it might be that different rules give the same rest string, and then we only need to match it once. We don't need to match it multiple times. Maybe. And so let's make this a map, a hash set, so that we can like memorize the results and don't have to do it multiple times. So, but the rest should be, again, we go through all the rules. We say we go through all the possible rests, and we say rests S is true. We go through all the possible rests, and we will match the next rule against the string. So m equals r dot matches this rest. This will give us a range of matches that we can continue with, which we will just collect. Next equals true, and now we swap rests and next. Okay, so what am I doing? Make, yeah. So we check one rule after the other, and all the possible rests of what this rule would match are collected together. And so next will contain the union of all the possible rests. And whatever is the possible rest of rule n must then be like a valid input for rule n+1 so that we actually match, right? And so, but if at any point in time the length of rests is actually 0, right? Like if at any point in time there are no more possible rests that could possibly be the remainder of a match, that means this concatenation can't possibly continue to match. Like, this is also apparent from the code. We could also just let the code continue to run, because this loop will then be empty and nothing will be appended to next, and then we'll be swapped around and we will continue and continue and continue. This is just a little bit of a shortcut. And now we need to collect the rests, because we need to return a slice of string. It might actually make sense in alternation to also do a deduplication, but let's not care about that for now. My variable names are kind of random right now. I kind of apologize for that. And we return a list of things. And now this hopefully builds. It does not build. Cannot convert this IDX. It does! Words match the rules. Oops. It compiles, it builds, it does things. I don't know what it does, but it does something. The resolve ref doesn't seem to do anything. This is surprising. Okay, so something seems to be broken, because I would have expected these to be resolved to the actual rules that are matched. So let's see what's the damage. Wait, I do call resolve refs, right? Yeah. Okay, good old printf debugging. Does it at least see that we have 0, 1, 2, 3, 4, 5? No, it says none of these are refs. This is right, because of course, because the slice of rules doesn't contain refs at the top level, but it contains like alterations and stuff. So what we actually need to do is do this recursively, and so we will add a resolve refs, which will just do the ref resolving recursively. So yeah, the problem is our top level slice will contain lots of like alternation rules and whatever, but not the actual ref rules. So we say resolve refs with a slice of rule, and it may return an error. That's fine. And now instead we will say for all the rules, if r equals resolve rule.resolve refs with all rules, return the error, otherwise return null. And now like every rule will be responsible for how it resolves itself. And so literal rules are very easy to resolve. Because literal rules can never contain a ref, so they will always return a null error. Concatenations will just rules go through all subrules and tell them to resolve themselves. The same will go for alternations. And refs are the only thing that actually do something when they have to resolve themselves. And this will basically be what we had before, which I guess I deleted. Great. So a ref resolves itself. It actually needs to be a pointer after all. But we can do that because the ref now needs to self-modify. Let me take a swig. So refs resolve themselves by saying their reference is the rule that it's at their index, and if that's null, it says nope, unresolved reference. Otherwise, it returns null. Yeah, so this now we need to make this a pointer because we actually change it in place, because resolve refs doesn't return anything because we don't want to propagate all of that up. Which also means that when we create the ref, we need to make sure that we create a pointer. Yeah, and let's hope this works. Undefined, concatenated, no wonder this is undefined. Missing return, yeah. Alternation will have the same because it's copy-pasted. Yes, okay, great. This, this is an endless loop. Why is this an endless loop? Where is it an endless loop? We should first check that. It's an endless loop in resolve refs. Concatenation.resolve refs. In here, r.resolve refs. Range rs. Can the concatenation contain itself? That why would this be an endless loop? Like, especially given that everything else is just values, so I'm a bit confused. 1, 3, 4. This is this. Yeah, that's fine. And then it goes like 1, 3, 6, 1, 3, 6, 1, 3, 6, 1, 3, 6. It always calls itself. But R is definitely this R. Just to make sure. Anyone see? So all the recursion will pass the list. Yeah, like, because we need to. So we need to the ref. Yeah, oops. The ref contains the index it originally referenced. And we need to wait until like all rules are passed to actually resolve what this integer corresponds to, right? Because it could be defined after this reference is used. So if the ref wants to resolve itself, it actually needs to get past a list of all the past rules, right? Because it needs to then look up its own index in this list of rules. And this is why we pass this list of rules to this roots to that we actually passed out. And like basically nothing in the tree of references will roots will ever care about this slice. The only thing that cares about is the ref, and the ref only cares about it to resolve itself. Yeah, hope that is hopefully that's a bit clearer. So why is this an endless loop? I don't understand why this would be an endless loop. For all the rules, resolve yourself with the list of rules, and then this does nothing. This calls it on an element in the list. Okay, like I'm not dumb, right? This should only ever be an endless loop if one of the slices contains itself. Shouldn't it? How to debug without a debugger. I don't understand this. I really don't. So this will always be like stack pointer is the argument will always be the same. The argument is this, yeah. Feels like you need a break somewhere. You mean like a break as in a break, or a break as in maybe you should print the list content. Yeah, I think printing this will be the right thing to do for now, just as a but I mean we do print the lists up here, and this is already super recursive. I got a feeling the content in the list contains duplicates. Yeah, but even if it does contain duplicates, that wouldn't matter, I think, because like we use values and all of that, and then also like that wouldn't explain the endless recursion, right? Like the endless recursion can only ever happen if one of the lists that we recurse into contains one element that we've already visited. So let's see what happens if we just print not the list of rules. What happens if we print an R, I guess. Let's see, this will 415, 415, 415. Okay, so why? Okay, so give me this. This is a concatenation. So R is a concatenation of concatenations. Okay, give me a pointer to the first element. Rule does not support indexing. Yeah, this is not surprising. This shouldn't be a dot. Yeah, it does actually, like there is just a rule, a concatenation that so it does actually seem that this concatenation that we visit contains itself, right? Because we can see that it ranges over it. Whoops. Yeah, so I think this is the issue. This is not supposed to iterate over all the rules that exist, but just over the subrules of the concatenation. Yep, that does seem like it would do exactly what we are observing. Yes, great. Okay, so problem solved. Crisis of faith averted. Thanks for the input. That was helpful. Okay, so it does return, like, it resolves some references now. So 4 is a reference to just A. That makes sense. And now this is like, okay, so this is unreadable, but it does look like decent, right? So like 1 is now a reference to all this. All of this should be what 1 is. And like, if we look at 1, that does seem appropriate. Yeah, it does. Like, I would just count that as 1. I think this actually resolves references correctly. Cool. Whew, so just for the record, does everyone understood what I did wrong here? I hope everyone understood what I did wrong here. It's a silly mistake, but sometimes silly mistakes just happen. Okay. To be fair, like, just I want to acknowledge the elephant in the room. Yes, with more meaningful variable names, it might have been more obvious that I'm screwing things up here. And yes, I understand. I also completely agree with the haha comment. It is not the brightest code ever. But again, we are going for the stars first. And we're already like a good hour in, and we don't even have 1 star yet. So we have to actually get cracking. Okay, so but our matching doesn't do anything yet. So let's for now we no longer need to print the rules because we are somewhat confident that that our rule matching, our rule printing works. Yeah. Now we actually want to verify that the matching works. So let's just take the rest of the example. 0 words match the rules. This is not as expected. We would expect, for example, in the above example, do not producing the answer 2. So we want A2. So in AB, ABBB should match. So we will just use that as a troubleshooting aid. This is the one that should match, right? Yeah, so why doesn't this match? Cool. Again, good old printf debugging. Let's also, for the record, let's in the ref printing code, let's leave this out. Let's just do this, because otherwise this will become too unreadable. Okay, so I guess I should do it this way. Rests equals append rests m. I assume the concatenation thing is wrong because that's just too much to ask matches, and we should like actually print the the rule just to be completely clear. Okay, so AB, ABB. Why does it print a dot? Anyway, AB, ABB matches A. I should also put the rest in just to be completely obvious in what we do. Okay, so AB, ABBBB matches a string A and gives you BA, BBBBB. BA, BBBBB matches 4 and then 4. 4 and then 4 is an A and an A. Why 4 and then 4? Oh, that's rule 2. So we actually need to do something in the concatenation to get us like all the way there, which I am not looking forward to. Oh, what to do? Printf debugging is reaching its limits, but I am not comfortable enough with Delph to do that right now, to go into that right now. As M is the rest, and it matches the rule. Okay, so AB, ABBBB matches this literal and gives as a rest B. So let's go from BA, BBBB matches 4.4, so this should be rule 2. 4.4 is AA. It shouldn't match 4.4. And not with rest 4.4, BA, BBBB. Okay, so once again, I am not sure what is going wrong. Let's see. This is the substring we are trying to match. Because I'm pretty sure the concatenation is wrong. Let's actually, for clarity's sake, do something simpler. Let's just change all of this to like a simpler rule. One word match. In this case, it actually does match. Oops. Yeah, I know. It still matches. It's not supposed to match. 1, 2, 3. A, B matches A and gives rest B. B matches B and gives rest empty string. This is more complicated than I would have hoped. I'm struggling a bit right now to see what's wrong. Okay, so we have 3 parts and it doesn't seem to recognize, like, so it shouldn't, like, this shouldn't actually match, but it claims that it matches. The concatenation stuff is hard. I don't understand why it is so hard. It's not, I can't imagine, like, I feel like I'm missing something obvious. I feel like this is probably one of the hardest problems I've had so far. rests equals next if matches rule this. With these rests, and the string is this, and the rests are these. Let's see what this outputs. Okay, checking rule once against not quoted, yeah, whatever, it's fine. Against this, AB matches the literal A, I guess. This is this is in the literal code. I would actually just, for clarity's sake, do a short file, I want to say. Yep. And now we can do a so let's see. Okay, so AB matches. So it is checking rule 1. Rule 1 is the rule. So it checks and it says the rest is B. So then it says sets rests to B. That's fine. And then it goes on to the next. So it says checking rule 2 against map B. So now the only possible rest is B. That's also fine. B matches this with the empty string thing. That's fine. And it says this rule, the string matches, and the rest is empty string. And now it says checking rule 3 against map empty string. Empty string matches. This shouldn't match. Is the first thing to see. So this says it matches, but it doesn't match. Yes, because this should actually just return nil if it doesn't match. So now this actually works. Okay. Now to something harder. Okay, it doesn't tell me whether or not. Why doesn't it do this? Doesn't it get to this point, or am I? Oh, sorry if I'm moving the table and or the camera. Because this is also something I did wrong previously in a previous stream. We never stop learning. One words match rule. So this actually matches now. Okay, so we can now actually try. Let's try with the full test input again. So this actually suggests that like at least the first problem we found was not in the concatenation, even though that's what I really thought. Okay, so this actually seems to work just fine. So let's remove our debug, because like now obviously everything is bug free, and we will never need it again. Cool, and let's just run this against our input. 147. Let's see if that's the correct answer. It's the right answer! Woo! We got a star. Great. Oh, God. A bit of printf debugging. I apologize humbly. I legitimately, like, ever since I started using Go, I stopped using debuggers. Because for the most part, like, when I get something to compile, it usually just works. And if I can't, like, the kind of problems I write can usually just be really, really solved simply with printf debugging. I used to use a debugger a lot more. Yeah, but then also, like, when I tried to use Delph in the past, I was not super convinced. So anyway, let's get on with part 2. So as you look over the list of messages, you realize your matching rules aren't quite right. To fix them, completely replace rules 8 with the following. So we just replace the rules. We don't have to replace anything in the code. This small change has a big impact. Now the rules do contain loops. Oh no. Oh no. And the list of messages they could hypothetically match is infinite. You will need to determine how these changes affect which messages are valid. Fortunately, many of the rules are unaffected by this change. It might help to start by looking at which rules always match the same set of values and how those rules are used by the new versions of rules 8 and 11. I love this because I think that's what I did so far. So have we ever assumed that there are no loops in the rules? I don't think we have, to be quite honest, right? Like, we did in the printing stuff, but we only did that for the references. Oh no, we did that for the printing stuff because the printing stuff now... Oh no, like, to have loops, it needs to use references. So if we now print references just by their integer identifier, we can't have loops anymore. I don't think we ever actually assumed there could be a loop, right? Can someone please like leave a comment if I leave something in the chat if I mentioned at some point like I do remember that at some point I mentioned luckily we don't have loops, so we don't have to care about this, but like, can someone point me to something where I might have assumed that? Because I don't think I have. I think this should just work. Which makes me think that the reason I was struggling so much with this part 1 is that you're supposed to find an easier solution that doesn't just generally work. I feel like this just generally works. Why is it doing this? It sometimes does that. I have no idea what. Like, I use Go Vim, which is a Vim plugin written in Go, which sometimes does things that I don't understand. I'm not super happy with that. It seems to, like, I think its default setting should be to just not add anything. But anyway, it's fine. Yeah, so I think this should just work. Anyway, if it doesn't, we will just see that, right? Like, we will just see that our program runs into an endless loop, right? Yeah, yeah, I will do that. I will, for example, so this actually has, so yeah, this is a small test case. Small-ish. Let's just run it against this for one. Null pointer dereference. Where? 80. Resolve refs. Yeah. That's fine. 3 words match the rules. And the example says, after updating, a total of 12 messages match. Oh no, now we actually, without updating rules 8 and 11, these rules only match 3 messages, which is the number we got. And if we change the rule 8 to 8 and 11 to this, and 11 to this, 6 words. We want 12, I think, right? Oh, we want 12. We only get 6. So this There does seem to be something icky going on here. Let me write this down. And let's do the replacement again. So 11 gets replaced with all of this stuff. And 8 gets replaced with this stuff. So this says 6 matches match the rule. Cool. Which doesn't it find? So it finds these. Let's move that over here. Oops. And see how that compares to the list that they say should match. So this I find. This looks like this one. This one I don't find, it seems. Right? This doesn't seem to be, like, this seems to be one of the messages it doesn't match. Oh, God. I mean, oops. 1 second. Oh, yeah, it just works. Cool. Yeah, I'm contemplating how to like debug this. So let's first do this. The second one you match is not the second one in the other list. It's slightly different, I think. Okay. Let's try this again. Test case. This one. And this is the one I match. Yeah, it's very different. No, they're also like, yeah, Okay, wait. Let's just diff the two lists and see which one I don't find. I can also... Okay, so I don't find these... Which of these is the shortest? This is the shortest one. Let's look at this. Let's just be cheeky and remove all the stuff. Oops. And let's try to see why this doesn't match. So zero rules match sure. So we want more than 0 rules to match this. Okay, but like apart from that, nothing really changes, right? So let's see what happens when we try to match this word. So the topmost rule should be a 0. It would be so much simpler. Can we do that? I think we can do that, right? Yeah. because like for parsing it doesn't matter. Okay, so the topmost rule is a concatenation. So let's do our test, our debug output again, trying to match rule. So and okay, so let's see. Against the rule. %q, the string matches, and the rests are this. S matches, the rests are this. This should be fine. So let's see what this does. Lots and lots and lots of output. Cool. So lots of output. Okay, too much output. Okay, so it's trying to match the concatenation 8 and 10. We should probably also have the test case open at some point somewhere. GitHub, Merovios, AOC 2020, day 19, test case. Cool. So trying to match concatenation 811 seems fine. Trying to match rule 8. So rule 8 is this. Oh yeah, it's actually like it uses the two rules. Okay. Trying to match concatenation 42. 42 is the last one. Tries to rule concatenation matches, but I have no idea which concatenation that is. Let's add some more debug output just to make everything more noisy. Okay. Yeah. Let's also do the rest of the stuff. The rest of the matching. Against literal %q as string r, because double escaping isn't fun. And then concatenation alternation needs some debug output. And the ref can just Yeah, the ref can just doesn't need to be output, I think. Okay, checking rule has no rule outputs. Okay, so trying to match concatenation 811, trying to match rule 8. This is 42 or 42 whatever. So it says 42 or 42 and then 8. Okay. Checking rule 42. Oh, this is a freaking long loop. So against alternation, trying to match concatenation 42. Actually, this is something that we can do to do, like, just as we did this, we can also remove one indirection by saying if len r is 1, we can say a equals append a this, else do this, because this will remove the case that we just saw where it just says, oh, 42, that's a concatenation of just one element. Okay, trying to match rule 8. Rule 8 is 42 or 42, 40, and so now it tries to match the long string against 42 or 42 and then 8. So it checks rule 42 first. Checking rule is over here in the alternation. And 42 is the rule 9 and then 14. And then, or 10 and then 11. So 9 is 14 and then 24. God damn it, there's so much backtracking and looping involved, and I have no idea how to best debug this. Let's try to, I don't know. Let's try to devise, instead of trying to figure out why this very, very long string with this very ugly loop doesn't match, let's instead try to devise a very short string that should match the rule, but maybe doesn't in our implementation. So let's try, so what's the shortest match we can find for 8? That's the shortest match we can try to 42, which is the shortest match we can find for 9. Which is the shortest match we can find for 14, which is B. Oops. And then a 27, which is first 1 and then 6. A. Oops. And then 6, which is 14 and 14 again, which is BB. Okay, so we have matched. No, I lost track because, of course, I did. This does not make for good TV, as they say. None of this does. So how to debug this correctly best? There are a lot of loops. What we can try maybe is, I don't know if this helps. Like, we can try to output this as a finite state machine and then see whether I'm afraid I don't really have the time, to be honest. Like, I target 2 hours and we are almost there. We only have 15 minutes left and I have no idea what's going wrong. And I have no idea how to troubleshoot what's going wrong. And I assume if I would just do this, this takes a while, but it shouldn't take that long. Like, I assume if I just hope that this error doesn't happen, this will not work, right? Yeah. This is annoying the heck out of me. Because there are two, like, this is just too hard to debug right now. Without serious, like, without, yeah, I don't know. I don't even know how I would debug this even in a debugger, because like the minimum example I have is just too big. Like, this is just too big of a thing to check. We can make up something that has loops and see if it works. Like a smaller example that still has loops. Like, we can say 0 is a 1 or a 2, and like a 1 is a right like small, like, okay, so if we want a short thing, we want to say that like one of the, like 2 can just be the end of line marker, and 1 can be like either a 1 and a 2 or just a 2. Yeah, I mean, this would probably work, right? This says, no, I do need to do something more complicated than that. 1, 2, or I am running out of steam. I'm also running out of concentration after 2 hours. I don't know. I honestly don't know. I don't know how to approach this right now. Either it's a 2 or like, okay, so it's a 1 is either a 1 and a 2 or just a 2. I mean, we also want to have like, we do want 2 terminals, right? We want to have like A, and we want to have like B. And if we just say 2 is either 3 or 4, like, this matches either, this doesn't work. So it's either an A followed by a 2, or it's a B. Yeah, maybe this works. And like, this should match this, right? One word matches, okay. But apparently it doesn't, like, apparently it works, but apparently it doesn't run into the same looping problem we have in our test case, into the same matching problem. I don't understand what I'm doing wrong, because I was trying, like, I was genuinely trying to do the dumbest thing I could think of to actually solve this problem, and I just apparently, like, running into the, if you actually try to solve this correctly, this is far too hard case. I hope, or maybe I'm just an idiot. Maybe I'm just a drooling idiot. This is not good. Not good. I don't know what to do. really out of my depth. Any ideas? Any ideas right now? Like I am happy, thankful for any hints. But yeah. A smaller test case would be so fine. Wait, I mean, we can try to find a smaller test case, right? We can look at, I mean, we have test case, right? Like what happens if we just try to remove lines from here? So let me just do get rid of the log output for a second. So what if we just remove lines? This also doesn't match. Like but I have no idea if it's supposed to match. Frick. It's not just that the test case of rules is just so freaking long. It's also the. Wait, what happens if we just replace one of the rules? What if we leave that as what it was before? 4231. What if we do this? Still doesn't match. What if we replace 8? What if we go back to 42 for 8? Wait, what was 8 before? Yeah. Then at least we know. Yeah. So this now matches, and this no longer matches. So this is already like, okay, so this is already telling us we fucked up majorly, right? Because if it matches, if we like, if this matches but this doesn't match, right, we definitely screw something up, because by adding another case to the alteration, this should strictly increase the number of things that can match. So the fact that like this doesn't match, but this does, like this tells us something. This tells us something. This is good. This is information. It also suggests that maybe we did something wrong in the alteration, which is surprising. Which is really surprising, because the alteration seems super simple, right? But like, yeah, this is it must be this. Okay. Either the alternation is wrong, or the way we interpret the results are wrong. And I'm inclined to think that this isn't wrong, because this is just so freaking simple, right? Like, the definition as matches returns a list of the possible rests after this matches, and if this list is empty, it doesn't match, and if it's not empty, it matches. So if everything was correct, right, this would go through all the subrules of the alternation, match the string that we have against it, and add it to the list of possible submatches. Of possible rests. And if any of them is empty, that doesn't matter, because we will just append an empty list. And if any of them is non-empty, that case obviously matched something, and we will output something that possibly matched. So like this looks good. I will not entertain the idea that this is wrong for now. I am always willing to blame the concatenation, because that code is just far too complicated for my liking. Okay, but like alternation, let's say alternation is right. So reference, well, how is that supposed to be wrong? Like, this literally just calls it subrule and checks if it matches and returns the result. This can't go wrong. Literal. Can the literal matching be wrong? If S has the prefix, let's just for my own sanity check for the documentation of has prefix. So this says if S has the prefix. So the prefix comes later, and the prefix is the literal that we are trying to match. And if so, we strip the prefix out using S_slice, and that is the only possible rest that exists if we match the literal. This looks good, right? Like if one of you sees something where I went wrong, please scream in the chat, right? But like this looks good, right? I think this looks good. This I don't know. I think this looks good. I will put that. This looks good. Concatenation. Let's see. Do we have anything else? No. Concatenation. So concatenation is the most likely culprit of anything. And let's see if we interpreted all of this correct. So rests as okay. So again, we want to return the lists of rests. So rests. The map rests should contain at the end. Is it possible string len minus? Is it possible string as? Ricky, I don't think I understand your comment. I assume you're referring to literal the literal matches, right? Like I assume you are referring to this. But like one thing to keep in mind is these are braces, right? They are not parentheses. So I remember for the list of empty string we're supposed to return. No, I think it's fine to return a list with one empty string because that just means we matched, but this is the end of the match, right? Indeed, we are supposed to return a string of a list of one empty string if it matches exactly. Like that is the expected output. And so like in this case, if this is empty, that should be fine. This should just be a list of one empty string. Can end up with an empty string, you mean? Yeah, like it can end up with an empty string, but that's correct, right? Like that is what we would want. And then we return an empty string, and then the empty string should get matched against the next rule in the concatenation, which should then fail and remove the thing again. So again, I feel this is fine. Let's look at concatenation.match. Rests is the list of possible rests. Okay, so next will be what we can end up with at the end. So we will range over all the rests, all the possible rests. So a thing matches if yeah, this just it feels so good, so correct. It just so we iterate over all the possible rests and we take the next rule and match it. This could be an empty string. Oh, I think I know my issue, and I think I thought about that. Maybe? Wait, let me consider that. Because What I'm wondering is, no, this is a concatenation. This is not an alternation. It's either way. So what I'm wondering is, wait, let me think about it. Let me first go through the rest and see if I see a different obvious problem. So if the length of rests, if there's ever no rests left, then that shouldn't match. That seems fine. This is, by the way, wrong. This should just happen here. I'm also afraid I need to take a very quick break. Anyway, we have now overshot the 2 hours, but I feel like I want to address this. So let me take like a 5-minute break. And during that time, I will think about it and hopefully come up with something. Because like I feel I have an idea of what's going wrong, but I can't articulate it yet. But yeah, let me take a 5-minute break. See you all in 5 minutes, hopefully. Okay, I'm back. And I still have no clue what's going wrong here. This still, like, it looks, the logic seems sound, but it obviously isn't. One thing I would like to do for now, to pacify myself, is to see if we would really like to see. It would be bad if we match, but the rest is not shorter than the string we put in. So let's see. Like, ideally, every rule that actually match and output a rest should output something that is shorter than whatever we put in, right? Otherwise, we would just do an endless loop. So let's just see what happens if we do this. Why is this panicking? What is M is a types int and string. Why is M? Why is M an integer? Am I? Oh God. Yeah, you can tell that I'm not necessarily in the best headspace right now. So no panic, at least. So this is good. This is at least something. Now we go over all the possible rests. And we see if the next rule would match any of them. What I'm wondering is whether there's like something going on here with, like, depending on what the previous rule was matched. But like, it's not. It's just, it doesn't matter. Like, once we swallowed, like, once we matched the first piece of the concatenation, it doesn't matter which piece we actually matched. It only matters what rest strings we can reach. Let's see if this is like yeah, you can. Sure. Let me. This is alternation. Yeah. Rests. Does that help? I don't see anything. Yeah, so I'm a bit disappointed in myself right now. For all rules. But the logic is sound, right? Like, if we have the concatenation, like 114 or whatever, we first see whatever one would match. Why do we need to consider the second result? Which second result? Non-empty result. Do you mean in alternation or in concatenation? the reason is is that we might plug in the alternation. We might plug something that is the concatenation of two other rules, right? Let's see. You could have like something like I don't know. Like you could have like AB, and you could have the rule A, and then you could have the rule C, and then you could have the in this case you could have like 4 and then 3, and then like 4 is something like 1 and then 1 or 2. I don't know. And if you match that against ABC, you first have to check like 4 could match 1 or 2, and like it turns out 4 could match either, like both AB and A both match this, right? But if you only, okay, so now of course let's do it this way around. But if I would only return the rest that for the match of 2, we would always say, okay, so we match A and we return BC as a rest. And then so 4 would say, okay, so I match and the rest is BC, and then 0 would look at, okay, so 4 matches. Now let's look at 3. Oh, 3 is a C. And then it says, oh no, but like BC doesn't match 3. But it doesn't match C because it starts with a B, right? This is why 4 needs to return both, because like this is why 4 needs to return both BC and just C, so that like if 4 then tries to match the next thing in the concatenation, it actually gets something that might match. Is that clearer? Right, the alternation might be plugged into something, like into a concatenation that would then match or not match depending on the rest. I do not know how I want to fix all of this. What is going wrong here? What happens? So what happens if a rule doesn't match the rest? It doesn't really matter as long as so in a concatenation, if one piece doesn't match one rest, that doesn't matter as long as it matches one of the other rests, right? Like in this case, we get like if we pass in BC and C, it doesn't matter that the 3 doesn't match this as long as it then matches the C after that. So this is why we iterate over all the possible rests we have right now, and we check the next rule against that. What I'm wondering is, wait, no, we only use next after we iterated over all the rests. That also seems fine. And we only reject that if we ever get a rest that does not, I mean, technically speaking, is this correct? What happens if we remove this? Zero words matched rule. Oh, that's still the same. Okay, so this is at least not the problem. What happens if, just for the sake of argument, we return this map logic? Because this map logic just makes things more complicated. Let's for now not care about duplication. Is this... Yes, seems correct. This now must be like this because it's a slice. So cannot use R. Yep. But we don't need this. Okay, still no change, which is what we would have expected. I see it coming that this is not at all what we should be looking at, that we like there's some other part of the logic that is just wrong, and I don't know why, and I'm like, I mean, one thing to also like that's also interesting is when we changed the rules, we noted that one of the things here, yeah, there was a nil rule in these. Wait. Right? This is interesting. What happened here? Why does this return a nil rule? Like, why are some of the rules nil? If this is the issue, I will go mental. Yeah. At the time, I was just ignoring that and thought like, yeah, that seems fine. Like, if it's nil, just skip it. But no, the past rules should never be nil. Would we ever return a... Okay, so wait. So they are... no, they are... This is actually fine because there are actually gaps in the input in this case. So this is actually fine. Okay. Okay. Okay, does it pass the rules correctly? Let's just go through everything we can possibly think of for why this would be wrong. So 0 is 8 and then 11. 1 is just a literal A. This makes sense. 2 is an alternation, either 1 and then 24 or 14 and then 4. Right. Yep. Yeah, this just looks fine. It's just there's nothing wrong with the parsing. But this is just too much code. Okay, so I will do one more thing now, which I have no idea if this will even help. But I will write out dots code to see like to write a finite state machine to see what happens, I guess. I don't know if I want to do that. No, I don't want to do that. This is even more complicated. I don't know. I'm sorry. I don't know what to do, and I don't know if if it makes sense to continue if I don't know what to do. Because like I have no idea how to debug this, and I like just staring at it and hoping that the bugs go away won't help anyone. Is this logic, is this correct? We look if any of the rests is is non-empty. If so, it's not a match. And then we want at least one. So we want at least one empty string as we want at least one. Oh, actually, oh god, actually this is wrong. This logic is wrong. If this is the problem, I will. Oh, this logic is wrong. Because we just care about like if any of the strings that are contained is the empty string. This is what we want. Yes. So let's check the full example. Let's check the full example and see what happens. Oh god. No, this is not what we want. We want this. 3 words. This is not the right number of words, is it? Oh yeah, it is, because this is not the full test case. Because we need to stop laughing at me, or I guess no, it's fine. Just laugh. It's okay. I'm fine. I'm fine. I can't believe it, but I'm fine. For the record, strictly speaking, there could still be another bug in there. "12 words. Well, who would have thought? 2 words, 12 words might actually match. Wait, before we do this. So the reason to redirect the stdr to dev null is that the output, that it will not be bogged down by printing to the terminal, which is sometimes slow if we have a lot of debug output. Yes, that was the actual problem. Holy fuck, man! Sorry for cursing. No, I'm not sorry. I am actually completely fine with cursing. So we actually got 2 frickin' stars. So let's remove the frickin' log output, because holy yeah, this is fine, I think. Okay, just see that it's still, yeah. And now it shouldn't, yeah. Now it also runs, like, without all the debug output, it also runs significantly quicker, faster. It actually runs fast enough that I will not bother. I don't know. Yeah, no, I think, I don't know. Let's do the responsible thing. So let's clean up my matches, their matches, and test case we also no longer need for now. Yeah. Yeah, I mean, honestly, like methodological debugging should probably use a debugger, but also like in this case, it probably wouldn't have helped. Um, oh God, yeah. I think I'm honestly, I think I will leave it at that and enjoy the rest of my evening. Um, Thank you all for joining. Like, really, it was super helpful and it was super fun to interact. I but I don't think like I'm already over my allotted time, and I don't think I want to. Like for the record, if I was going to fix that, like fix all of this, obviously I would like add some comments and stuff. I would add test cases. Some things I would do is obviously like I removed in the concatenation, I removed all the map logic with the deduplication. I would probably reintroduce that, but I probably wouldn't use a map. But I would probably use a slice of strings that is sorted by length, or like sorted and sorted by length, with the idea that shorter strings we can reject quicker. So it probably would make sense to like if ever you keep a list of potential matches to really take the shortest first. Is one thing I would probably change. Apart from that, I actually think the code is pretty good. I would like, yeah, apart from like documenting it and maybe making that change, I actually think this is like there are a couple shortcuts where you like can do like if the length of rests is 0, but yeah, no, I think this is fine. I will leave it at that. Thank you all for watching, and I will be back tomorrow at the same time, like 5 p.m. German time. I will do day 20, and hope to see some or all of